Hi, hello, welcome to today's my PPT presentation. I am Vishwadeja from CSC. Today my topic is about the Schrodinger and his contribution to quantum physics. This PPT consists of quantum physics, about Schrodinger, contribution to the quantum physics. Quantum physics. Quantum physics is a study of matter and energy of most fundamental energy level. It aims to uncover the properties and behavior of every building blocks of nature. The quantum discoveries have been incorporated into our foundational understanding of materials, chemistry, biology, and astronomy. Quantum physics underlines how atom works and so why chemistry and biology works as they do. About Schrodinger. Schrodinger was born on 12th August 1887, 4th January 1961, sometimes written as Edwin Schrodinger, was a Nobel Prize and in who developed a number of fundamental results in quantum theory. The Schrodinger equation provides a way to calculation the wave calculation function of the system and how it changes dynamically in times. He wrote many he wrote many works on various aspects of physics, statistically, mechanical and thermodynamics of physics, etc. In popular culture, he most known as Schrodinger's cat through experiment. In 1927, he succeeded Max Planck at an university in Berlin. He received a personal invitation from an mathematician himself to reside in Ireland and agreed to help establish an institute of advanced studies in Dublin. In January 1926, Schrodinger published an paper on wave mechanics and presented what is known as Schrodinger equation. Now, the contributions of quantum physics. He described the equation describes what to do under almost any circumstances. To do so, one need to insert a term that describes the situation the V. If an electron is somewhere that nothing happens, V is 0. If it gets close to an atom nuclear, V will be a different formula. The mathematical slide B is beyond the scope of this article, but the result falls within the boundaries of an interest. Initially, it shows how complex the atoms orbits with their various shapes and either spheres and shapes of the dumbbells. Schrodinger expressed de Broglie's theory, the wave behavior of matter in mathematical form that is adaptable to the variety of physical problems without additional assumptions. According to the classical mechanics, if an atom of mass m is subjected to a force such that its potential V is x comma y comma z at a position x comma y comma z, then the sum of V x comma y comma z and the kinetic energy p square by 2 me is equal to the constant, the total energy E of a particle. A wave function psi x comma y comma z that varies with the position. Schrodinger replaced rho is above the energy equation with differential operations that the de Broglie's relation. Then he shows that the psi satisfies the partial differential equation. His requirement of an anti his requirement of anti-wave function for his lead to fundamental results known as exclusion principle, first proposed in 1925 by the Austrian physicist Wolfgang Pauli. Two electrons in the same atom cannot be identical set of values for the four quantum numbers n, l, m and ms. The Schrodinger equation cannot be solved precisely for atoms with more than one electron. The principles of calculation are well understood, but the problem are complemented by the number of particles and varieties of forces involved. The exponential function and the time-dependent Schrodinger equation reduces to the time-independent form. Any atom may change spontaneously from one state to another state with a less energy emitted. The differences in the energy as photon with a frequency given the Bohr's relation. If electromagnetic radiation is applied to a set of atoms and if the frequency of radiation matches the energy difference between two stationaries, transition can be stimulated. The selection rules for the radiation relates to the angular momentum property. The absorbed or emitted photon has its own angular momentum, and selection rules reflected the conservation of an angular momentum between the atoms and the radiation. Thanks for giving me this. Thanks for this opportunity.